Hi guys, this is Ms. Cry with Syracuse Academy of Science and Citizenship. Happy Friday! We are going to talk about sink and float today. Displacement explains why objects sink or float. That's a big word. Displacement. Displacement occurs when you place something in a fluid or any substance that flows and it moves the fluid out of the way. So that's what displacement means when we talk about displacing something. It's when you place something in a fluid and it moves that fluid out of the way. A Greek mathematician named Archimedes discovered that the amount of water displaced or moved by an object depends on the weight of that object. So, the heavier or bigger that object, the more water it's going to displace. This is a picture of Archimedes. Buoyancy is the ability of an object to float. Buoyancy. So in this picture, you can see the basketball is much larger than the pebble, but it's floating because it's less dense and displaces more water. The basketball is also filled with air, so it's more likely to float. As opposed to the pebble that's smaller but more compact, and it's dense and displaces less water. So there's no air inside this pebble for it to help it with floating. So it's going to sink even though it's smaller. Shape can help an object float. A ball of clay will sink, but a canoe shape made from the same amount of clay can float. Why would we think that is? So it's because the boat shape will push more water out of its way compared to its weight. So on the left, you can see a picture of the ball of clay we talked about. It sunk to the bottom. But on the right, it's the same amount of clay in a different shape, and it's hollowed out like a canoe or a boat shape. It displaced more water compared to its weight, so it's able to float. The amount of air inside of an object can also help it float. This is a really fun experiment to do at home. We can see this is actually the same type of fruit. So that we have two baby oranges, and what can we tell the difference between these oranges that might have resulted with one floating and one sinking? What is the difference? You can pause this video if you want and talk about it. So we see that the orange that is floating actually still has the peel on it. So that might have to do with why it's floating and not sinking. We just talked about how air plays a part in whether something is going to sink and float. And if we think about it, oranges actually have some air that's trapped inside of the peel that allows this to float. Instead of the orange that is on the bottom, it's sunk, it does not have a peel, and it doesn't have any air that's trapping inside between the peel and the fruit. So that is why it's sunk to the bottom, because there's no air that is allowing it to float. Even though boats are made from very heavy materials, they can float because of the large amount of air inside the hull. And the hull is this part that's touching the water, the actual boat part that sails on top of the water. This blue part, you can see there's a green part, that's the sail. Red part, that's the mast. That's not going to help us with whether it sinks or floats. It's the hull. So we've got air that's trapped inside of the boat. We have the steering wheel. Everything down here is going to help it float. Would an empty water bottle sink or float? It would float because it's hollow, or empty objects like ping pong balls or empty plastic bottles are able to float better than solid objects like baseballs or filled water bottles. So empty plastic water bottles have so much air where it's gonna be able to float on top of the water. A lot of times we think that heavy objects will sink and lighter objects will float. This is not always true because if the downward force or push of an object is stronger than the upward push of the liquid, the object will sink. If the downward force or the push of the object is weaker than the upward push of the liquid, the object will float. I know that's a lot of words. We're going to talk about this a little bit more. So in this picture, we have two glasses, each have water and each have an egg. But we can see that one is floating and one has sunk. So on the left side, this is just plain water and the egg has sunk to the bottom. On the right side, the egg has floated and it's still water, but it's salt water. So it's actually good to know the more salt you have in water, the more likely things are to float because it is much more dense than regular water. So the more salt you add to water, the more dense it will be. So the egg is actually not heavier than the salt water. Some heavy objects like boats float, while relatively lighter objects like coins sink. Buoyancy. The ability or tendency to float in water or air or some other fluid. How are fluids different than solids? So another word for fluids is liquids. So we're going to compare liquids and solids. But first, everything is made of matter or little molecules. So some molecules are very tightly packed together and others are loosely packed together. And these molecules are so tiny we can't see it with our own eye, but when they're all put together, that's when we see things like this. So this is an example of solid, liquid, and gas. Solid molecules, you can see, are very tightly packed, and it almost looks like a square. It's very structured. You can tell the shape of the object. But liquids are a little different. So they're still close together, but they don't have a defined shape, and they're going to move around much more than solids. So a solid, like this water bottle, has a fixed shape and a fixed volume, and it's rigid. So rigid means it's unable to bend or be forced out of shape, and it's not flexible. So that's what a solid is. But a liquid, like water that will be poured into that water bottle, it's not rigid, so it can bend, it can move. There's no fixed shape, and there's a fixed volume. So a fixed volume means it's always going to stay that amount of water. But no fixed shape means it will form to whatever object or shape the water is going into. So if you're pouring water into a fish-shaped glass, that water is going to form into a fish shape because of the solid glass you're pouring it in. What determines whether something will sink or float? We talked about this a little bit, but another word besides displacement is buoyant force. So in this picture, if the buoyant force is greater or stronger than the weight of an object, the object will float. So on the left side, that's what's happening. The buoyant force is greater than the weight of the object. So the buoyant force coming up from the water is helping it float because it's greater than the weight. But on the right, if the buoyant force is less than the weight of the object will sink. So the buoyant force, this arrow on the right side on the bottom, it's less than the weight of the object. It's not strong enough to keep this object floating, so it's going to sink. Why do things weigh less in water? Think about when you're in a pool. It's a lot easier to lift someone up than if you're on land. So they actually don't. They only seem to weigh less because of buoyancy, what we're learning about. It's the upward push of the liquid the object is placed in. All objects remain the same weight in water as they do on dry land. But because of buoyancy, it helps displace some of the water, and gravity is not pushing down as hard as it does on land. So that's what's helping in the water to help you lift things up. Why don't boats sink? Buoyant force pushes up against the object with a force equal to the weight of the object. So boats push the water out to the sides to make room for them. Why do helium balloons float? Try to think if you've ever tried to blow up a balloon with your own mouth, the air that's coming from your lungs. It's definitely not helium, it's regular air. It does not float. It goes right to the ground unless you're holding it or you're trying to throw it up into the air. Helium is a lot lighter than air. As long as the balloon is lighter than the air it replaces, the balloon will float in the air. All right, that's all I have today. Maybe you guys can go do some more experiments with sinking and floating, and I can't wait to see what you come up with.